Hello. Hello everyone, welcome to the live stream. We still have half an hour to go before the official seminar, which is already prepared. So we're going to play a few demos related to the seminar that we're going to have to fill up this half an hour. And if you guys want to chat, I'm going to leave the chat window open so you can talk your nonsense about the different demos that you're watching. We're going to watch some Spectrum stuff and some Space Bakes stuff. So yeah, let's get started with that.
The unreasonable deepness.
And Spectrum was always known for having a very peculiar style. It's a me, a Mario.
We operate from the underground.
Computer surgery. I didn't even remember this demo myself. It's looking pretty good. The unreasonable deepness with some quilt stuff. For those who just arrived to the stream, we're playing some older stuff from Spectrum and Space Bakes before we have the seminar. This is a classic. Hey, this is the bugged version, where the record spins the other way around. There was a bug fix to fix this. But apparently the video capture is before that. Singing kebab. That's just awesome. I love this demo. It's so ridiculous. This is one of the more controversial demos that they did, or that Space Pigs did when they first released. They ended up winning Breakpoint, was it? Winning or second place? No, I'm wondering. Second place, yeah.
Hello, Kevin. How are you today, Kevin? Did you brush your teeth today, Kevin? Oh no, Kevin. What happened to your teeth? Is this your plant, Kevin? Your plant is thirsty, Kevin.
So creepy.
Well done, Kevin.
Well done, Kevin.
What's on the radio today?
6, 5, 8, 1. 6, 5, 8, 1. 3, 8, 6.
Follow the instructions, Kevin.
Well done, Kevin. Oh yeah, the cheese challenge.
Where are you, Kevin? There you are. Can you name the animal?
It's Amiga, obviously. You get one ball.
Well done, Kevin. You are very good at soccer sport.
What are you doing, Kevin?
Oh, making a demo?
Kevin is coding a demo.
Wow. Some
Demo
rest
making
bars.
so much fun.
The origins of the pig. Oh, greetings. Nice. Cubase light. Perfect. Code in Pascal. Ah, it crashed. Yeah, just turn it off and on again. Oh my god.
Bravo, Kevin.
Yeah, people really love the surrealism of it all, and then it kind of became a trademark of Space Pigs. I think mostly brought by JCO. Was like the artistic director of these things.
North Korea is actually
Hey,
a
Black Pawn,
massive
welcome.
amusement park.
You're actually a massive amusement park.
With the power of communism, we deliver great art. My penis is very large.
Your penis is very large.
It is made from cheese. I gave it a name. It is a good name. The name is Amiga.
We admire your large penis.
My trusted followers make love to my Amiga. It is very huge. It is very huge.
Very huge Amiga that you should worship.
The power of science. I have created
The power of
one
science.
spider. It is atomic in nature. Behold the spider. I nourish the spider with my Amiga.
I nourished my spider with my Amiga.
Once I have been to the French country. I gave them the gift of cheese. With my many legs, I will
Kaiser is
crush
listening.
the imperialist menace. ICBMs of cheese will be the nourishment of your people's envy. One time, I have driven the socialist roller coaster. It made my puke taste of spider.
It made your puke taste of spider.
Your puke taste of spider.
Pirate. Johann, ein Bier.
Ein Bier, Johann.
Johann, ein Bier. Johann, ein Bier. North Korea. North Korea. North of Korea. Behold my Amiga. Johann, ein Bier. Johann, ein Bier.
You're actually a pirate.
Johann,
You're actually a pirate.
You're actually a pirate.
Johann,
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 You're actually a pirate.
Johann.
And of course, they're actually traveling in cheese. That makes every sense. Oh, I didn't remember it had greetings. Oh, future crew with 3 W's. Nice. It's the future crew of the World Wide Web. It's amazing. I love the surrealism. It's so different from everything else that we see in the demo scene. I'm gonna pause this for a second just to talk about surrealism in the demo scene, which is not something you see a lot. I mean, there's a lot of abstract stuff on the demo scene, a lot of weird stuff, but I mean, Space Pigs really delivered some quality stuff in the last couple of years with this whole saga of releases, sort of based around the universe of Kevin, but with also the Kaiser, and it's just really weird. And the more you see it, the more you try to make sense out of it, but you do know that they just made it like just let's come up with something really weird to do next, but it somehow fits aesthetically with each other. It's just great. I really love that there's these kind of voices in the demo scene, despite the controversies of getting placed high in compos and other people not taking them seriously because not being high-tech enough. I mean, those kind of discussions always existed with art demos versus technical demos. And I think they resonate a lot with a lot of people who want, counterculture stuff, anti-demos as Vern used to call them. There are demos that they are just standard demos. They have the same effects as usual, the same music as usual. And then you have to do anti-demos, which are still demos, but you do it in the complete opposite formula that you would normally do a demo. And that is interesting to explore for some people to just force yourself to get out of the box, try something different, see what works, what doesn't work, without following the specific formula for making a kick-ass demo. Anyways, let's keep watching. I still have 10 minutes left before the seminar, so I'm gonna play you a few more demos from Spectrum and Space Pigs, which is which the engine which is going to be talked about during the seminar was used for creating. So let's get back into it. So this was the invitation for Evoke 2018. Features some rap music, some bad rap music, according to people.
Die interstellaren Schweine mit dem Schwanz über der Schulter und der Szene an der Leine. Adelskrone links, Ernte 23 rechts, schieß auf ein Rival, die Letten, Helikopterschwanzgeflecht. Es ist 13:37, Gangster multisexuell. Wache morgens auf durch meines Hundes Cerberus Gebell. Schnell Pentagramm auf Boden kacken, ich muss jetzt mal lochen. Lese rückwärts aus der Bibel, werf sie danach in den Ofen. Mit Camembert und Brief, fahr zum Ficken im August nach Köln und es gibt Hipster am Spieß.
Wish there was English captions on this video.
Skala von 1 bis 10 halte ich dich für einen Hurensohn. Identifiziere mich als Hyperphallogen. Schneeflocken, Fotzen werden geboxt und sehen, das Verhältnis zwischen Schwanz und Seele ist reziprok.
Ritalin?
Es ist halt die Vogue.
And here's the Kaiser.
Weltraumschweine machen's vor, von ganz oben bis ganz unten blättern wir beim Masturbieren wie die Blöden in der bunten. Pickelhaube auf, Urlaub an der Havarie, es heißt die Guten sterben jung, Weltraumschweine sterben nie. Bärtige High-Class, Geishas machen Liebe lang, man Bang, Passage, Demoscene im Programm. Yeah!
Many cool deadlines.
Für den Tag, fahre nach Prag, hole mir den Golem für die Kölner Silvesternacht. Schicht im Schacht, Belästigung auf alchemistischem Niveau. Ich fress teilweise Nutten und spül runter mit Merlot. Yeah. 20.000 Petabyte Tentakel-Pornos sind für meine höheren Gehirne nur Aperitif. Bestimmt wird euer Dasein von der höchsten Instanz der Deutschland GmbH. Space Pigs, Motherfucker! Yeah! Pickelhaube auf, Urlaub an der Havarie. Es heißt, die Guten sterben jung, Weltraumschweine sterben nie. Weltraumschweine machen's vor, von ganz oben bis ganz unten blättern wir beim Masturbieren wie die Blöden in der bunten. Pickelhaube auf, Urlaub an der Havarie. Es heißt, die Guten
Very gangster.
Weltraumschweine sterben nie. Bärtige High-Class, Geishas machen Liebe lang, man Bang, Passage, Demoscene im Programm.
Speedfister. Schnapsgirl. Alcatraz. Alcatraz bars. The Mercury.
Pickelhaube auf, Urlaub an der Havarie. Es heißt, die Guten sterben jung, Weltraumschweine sterben nie. Weltraumschweine machen's vor, von ganz oben bis ganz unten blättern wir beim Masturbieren wie die Blöden in der bunten. Ich glaube auf Urlaub an der Avarie, es heißt die Guten sterben jung, Weltraumschweine sterben nie. Kommt der Troubadour, der Fotz, läuft der Käse aus den Boxen und der Fahrbausch ist es mir nicht mal ein Reim wert.
Of course, you end up screwing a fire hydrant. Obviously. What else would you screw at the end of the demo?
Nein, lass mal.
Not all of Mercury, specifically just last. Anyways, probably the last time we're gonna see before the seminar. Echo Chamber, released at Revision 2018, got 3rd place. Look at that chromatic reflection. Tunnel effect. Kevin Planet or Kevin Moon. Gotta reuse those models. Oh, it's just getting started, Black Ones. It's just the intro. To do this at a party place is great. And it says so much about the demo scenes, like such a good scene commentary at the same time as Robin's Yannick. Now 37. And Hadik means he's hairy instead of a birthday boy. Which, I mean, 37 is probably very hairy by now. There we go, a hairy version of Robin's Yannick doing the head dance acting. Ear clipping playing for the Tyresti and the Tandy. Obviously. Down thumping is good. If you're on Poet, down thumping will make your eyes pop. Shit, I stole him from Kuzma. Also, great idea. Let's just pick every single person who down thumped us and put it on screen. That's gonna give us some votes. And the really cool thing, there was a comment by Parallax there, so he down thumped his own demo. Are these seminars also restreamed during the main days of Inertia? No, it's gonna be just during September, but it's archived on YouTube, so you can check. If you go to the Inertia PT website, there's a link there for the archive of all the seminars we did so far. The idea was that you would watch a seminar and get inspired and actually do some stuff for Inertia. I don't know. It's sort of working. This on the Cables GL, people were very excited and started doing something. So I hope it keeps going the same way for the other seminars, but we'll see. Welcome, Parallax. So yeah, I think it's about time that we start the seminar. So the seminar, and I'll put my webcam on just so I can change the background while I pretend to do an introduction to Parallax. So Parallax was active in Spectrum and 500 other groups as usual. And after doing a lot of demos on Parallax, they started working on this new engine and they called it Bart. And Parallax will explain on the video about to follow the ins and outs of how they build the system and all that kind of stuff. So yeah, I'll switch it to him and let him explain because he knows a bit more, just slightly bit more about Bart than I do. So yeah, please enjoy the seminar. It will be around 45 minutes, and after that we'll have Parallax here for some Q&A. So feel free to either type questions on the chat or just ask stuff afterwards at the Q&A. So please enjoy.
Hello, welcome to my talk. My name is Parallax, and PS has asked me whether I'd like to speak a little bit about a demo tool I've been working on for several years called Bart. I'm happy to oblige, and I hope you'll get something out of me describing the motivation for creating the tool, how it can be used to make demos, and also how it works under the hood. But before I'll delve into all those details, let me just quickly introduce myself. So professionally, I've been working in the games industry for some years, mostly doing AAA conversions for titles on consoles, tablets, and PC. And currently, I'm working as a platform engineer for industry applications at Unity. I'm also a founder of the PC demo group Spectrum. And within Spectrum, I've been involved in several PC demos that were mostly made with tools I've been working on, because tooling is pretty much the focus for me in the demo scene. You can follow me on Twitter using the handle parallax_SD. And having said that, let's have a quick look at the agenda. So I'd like to separate the talk into two areas. First, I'd like to talk about the motivation for a new tool, what it's been used for and how it's used, and then I'd like to describe some technical aspects of how this is done. I'll only focus on the big picture because I think the architecture here is more important, and probably also more interesting than the specific details of how some kind of editor or service was implemented. I also have a small hands-on part that shows the basics of how to work with the tool, and some fairly recent stuff about gamepad motion capturing I implemented for fun. I'll also talk a bit about our integrated C# build system, and finally I'll end with a conclusion. So before I talk about the demos that have been released using Bart, it's probably sensible to just quickly talk about the origins of the tool and the name itself. Bart is German for beard, and the reason for that is that back in 2009 we wanted to make a quick game release for Breakpoint, and in the game players would play a hairdresser and work on several customers and improve their looks in some way, and we thought it might be sensible to have some kind of tooling to help with designing the levels. Well, it turns out the game was never released, we were never finished, but we had some kind of foundation that we could use to extend it and make a demo system, make actually several demo systems, and the current iteration is what I'm talking about in this presentation. So, another interesting tidbit is that Spectrum actually never released any demos using Bart. There's another demo group called SpacePix who have released 10 demos using Bart now. You can see 4 of them here on the screen. I guess one of the most known demos is Hello Kevin on the top left. Then there is the Evoke invitation on the top right, Echo Chamber on the bottom left, and the offensive demo. But as said, there are actually 10 demos that have been released, and some of them are quite successful. So let's talk a little bit about motivation for creating a new demo tool. As I said, Bart is not the first demo tool I've been working on. The previous one was called Henneke, and Henneke pretty much did what many other demo tools are doing, I guess, which is provide the means to instantiate some kinds of entities inside a graph. Each entity would be able to modify what a user would see on the scene, would probably have some kinds of properties. Those properties would be able to be animated by the user. There would also be some kind of sharing of data between entities. And I guess in a way that pretty much worked for us for a long time. But there's one thing that we thought was kind of missing, which is flexibility. Because you see, when we are working on demos, oftentimes we found that a specific entity would need some new kind of functionality or some kind of new property. And when we found that we needed some new functionality, the only way to implement that was to save the project, go out of the demo tool, open Visual Studio, add the new functionality, compile everything, reload the project in the demo tool, wait for everything to be loaded, and find out whether the functionality actually works or not. And so, in a way, that means we had pretty bad turnaround times. And when you have bad turnaround times, that also means that you cannot be as creative as you might want to be, because you're spending so much time just waiting and not working on your actual content. And so one motivation for our demo system that's embedded in Bart was that we wanted to do all that while the demo tool is running, without having to go into Visual Studio and reload the project and everything. It should just work while the demo tool is running and update everything instantly. Another motivation, at least for me, was that, as you will see, Bart is a pretty big piece of software, and I guess there's this argumentation that you should not put more work in and just be just go straight to the point where you want to go. Bart itself is pretty over-engineered, but I personally enjoy just, I guess, pushing the limits a little bit. And so I at least for Bart, I adopted this because I can mindset, which is something I can enjoy when doing it in my free time. Obviously, while working in a professional capacity, there are entirely different motivations and I couldn't do something like that. I'd now like to talk about the functionality of our demo system, and I guess it makes sense to do that from the perspective of a user who wants to make a demo. So the first thing a user would want to do is provide the project with a bunch of scripts. Each script is a text file that is either written in Lua or in C# and is basically a template for a node that can be instantiated in a graph later. A script might also include information about input and output pins, which is basically data that flows into the node, might be used in its calculation in some way, and then again flows out of the node. Now, when those scripts are all finished, the user would want to create a new graph and instantiate nodes based on those scripts. The user can also use output pins and connect them with input pins of other nodes and basically create a directly acyclical graph that is then executed in a known order. In this case here we have a viewport width that's provided by the red node and then consumed by another node, I guess for rendering purposes. There's also the possibility to animate input pins. We have a built-in tracking system that's based on the handling set forth by the GNU Rocket project. So we can just say bind a specific input pin to a column in our tracker and then enter data for that column, set interpolation, and basically drive how the demo will evolve over time. Now, when the user is happy with all the patterns he has created for a specific graph, he can then create a new sequence and drag the pattern data into the sequence timeline. And the alignment of those track items will basically describe how the demo is going to look in the end. We need two sequences for making a demo because we have a main sequence that's used for rendering the actual demo, and we actually have a always reused sequence that's used for creating our loading screen. Now, when the user is happy and finished with everything, the only thing to do is create the demo itself, and that's done by launching the demo export dialog. In the demo export dialog, there are certain options the user can tweak. Click the export the demo button, then all the resources will be collected, perhaps some extra code will be generated, depends all on the specifics of the flags the user has set. And out comes a single executable that's ready and can be released at the demo party. So now that I've described how Bart is working from the perspective of a user, I'd also like to do the same for developers. And I guess the first thing to realize is that Bart pretty much is comparable to the design of Visual Studio. The reason for that is that back when I started the project, I also worked with the Visual Studio extensibility model quite a lot, and it influenced me because I thought it's kind of cool how you can extend Visual Studio in so many ways, and I thought it would be a cool approach to have for a demo tool. And so the basic idea of Bart is that it's based on 3 pillars. The first is that I have a certain bunch of core services that are so integral that it makes sense to just have a base implementation that can be used by any functionality within the tool. Stuff like being able to create new editors or launch new editors. Stuff like using the status bar, writing output to the output log, and so on. Then the next pillar is that there are certain basic UI elements that the tool just comes with, like obviously a main window. Then the main window has docking functionality, and there is other stuff you know from Visual Studio, like it has a solution explorer. It also has an output view for logging stuff to different tabs, and more demo tool like things like a property grid, and elements like that. And third, there is this concept of packages. And the package is nothing else but just an assembly that resides within the directory of the demo tool. And the demo tool will use reflection to find out whether the assembly actually is a package. And it is a package when it implements, in my case, the iPackage interface. And when it does, it uses that package to extend the functionality of Bart tool. And in the next slide, I'd like to go a little bit more into detail for what a package can do. Now, this is a visualization of the different components a Bart package might contain. As you can see, many of those components are factories. As an example, an editor factory that's added to Bart means that Bart can now launch a new kind of editor. And in that same line, we also have support for project factories, project item factories, or property designer factories. Property designer factories are factories that can extend what can be shown on the property grid. There is also a possibility to extend the context menus within the main window and within Solution Explorer. And it's also possible to add new system services to the registry. Those services can then be consumed by the package itself, or other packages also can consume the services coming from a different package. Then there's a concept we are calling named pipe command handlers. That's a convenient feature that we are using as an example when exporting data from Cinema 4D. We have an exporter plugin, and that exporter plugin can talk to the demo tool directly using named pipes. And the named pipe command handler then basically will interpret whatever the request from Cinema is wanting and send out some reply data. And last but not least, there's also custom initialization code, which is something we are using for our demo system to launch extra tool windows, such as the actual demo window that renders our content. Having said that, obviously this is an abstract description of what a Bart package does. We have a concrete implementation that realizes our entire demo system, which is called Stubble. And the next slide is going into detail of what Stubble is actually doing. So this is actually just a summary of the functionality of Stubble, since Stubble is going to be a larger part of my presentation, spanning multiple slides. Basically, as said, it's our demo creation package of choice. It comes with a standalone player, has an engine window and various editors, some of which I have been showing you beforehand in the description of how to make a demo from a user perspective. Then it, since a while, also comes with an integrated C# build system I'm going to elaborate on later also, and its focus is on rapid prototyping. I've just earlier looked at my initial commit for this package, and it seems that it's already 5 years old, so time flies. Before I'm going to delve into the architecture and certain components of Stubble, I'd like to give you a little bit of a hands-on presentation. Okay, so we are in Bart, and the first thing I'd like to do is open the sequence we are seeing in the Stubble render view here. So let's double click that, and the sequence editor opens. And inside the sequence editor I can just click play to see what's going on currently. And as you can see, basically we have some kind of tunnel, and the tunnel is animated in a particular way. Okay, so if we want to see how this animation was actually done, I can just double click a default pattern here. And it opens the tracker with one binding to a input pin called distance. In this tracker I can just move along and change values using the keyboard. And when I'm doing that, it has a direct effect. If I want to see how the graph actually looks, I just go to the Graph tab, and I see that here in this case my entire graph just consists of one node with 3 input pins. Distance is bound to the pattern editor, and the other 2 pins are unbound. So I can change them using the property grid if I wanted to. So if I drag along here on the X property, then you can see that this changes the rendering of the render view directly. Another way to change the rendering of the render view would be to connect it to the output of another node. And I've prepared a very simple node called modify. Let's create one here. Modify has only an output pin, so let's just connect the output pin to the X input pin of the quad, and let's look what that is having as an effect. And you might see that the X property is slowly getting smaller and then larger again. So I might want to change the frequency of this code. And so what I could do is just double click the modify node, and it opens up the text for the modify node. Let's just dock it next to the graph here. All right. And now, as you can see, the text itself basically consists of a Lua table called modify. It has an initialize function, it has a shutdown function, and it has an execute function. And the execute function basically does a sign calculation with a hard-coded frequency and hard-coded scale and hard-coded offset. Now, I might want to introduce a new pin, which I can then modify for the frequency, something like that. So there's this create inputs function. If I change that to add a new input pin called frequency, then I can down there in the execution of my node use that. So instead of self frequency, I would write i.frequency.value and save everything. And as you can see, instantly modify is a new property called frequency. Now frequency is 1.0, but perhaps I'd like to have a frequency of 5. Now let's look at it again. And as you can see now, this whole horizontal changing of our tunnel is considerably faster. Another thing I might want to do is just sever that connection again. Go to the pattern editor and add a new binding to X. So let's select quad 1, X. Let's make that column a little bigger. And then basically I could just enter some values there, copy paste that a little, and we would have some nonsensical stuff like that. I could also change the interpolation. Now everything is linearly interpolated, and it should make a visual difference, as you can see. And basically, that's what I wanted to show you for hands-on. As said, if the user was happy with the result, F10 launches the export dialog, and export the demo would create a new demo. Okay, so we're back with the slides. This illustration here shows the Stubble package and all the components it contains. I'm not going to describe each and every one of those components. It's just suffice it to say that all the editors and all the functionality I've been showing you earlier obviously has to be realized in one way or another. I guess one thing that's interesting to point out is that we have a dedicated resource monitoring service. That's a service that tries to find out whether all resources that are currently used within our system are up to date. And when a user changes a resource using an editor, or when a file changes that's linked to a resource in the file system, then the resource monitoring will try to reload the resource or the entire scene. Resource monitoring itself also uses other services, such as the file system watcher service, which is a base service of the Bart tool, and just subscribes to the changed event and reacts on any files that are changed. Then we have named pipe handlers. The scene importer API is basically what I described beforehand when we want to export data from Cinema 4D. And then there's also extra support for C# compilation, which is needed because we have dedicated Visual Studio support. We can tell the demo tool to generate a Visual Studio solution and include all the Lua and C# scripts that are part of our Bart solution. And then users can just use Visual Studio. And within the Visual Studio project, users can just run the project, and running the project based on the selected configuration will tell the demo tool either to recompile its state and update everything, or to allow attaching of a debugger. Last but not least, we have two tool windows. One is the Lua REPL, which is basically a text editor where you can evaluate the current Lua state. Nowadays, we are not using it as much as we did in the past because most of our logic is now C#, but it's still there and it's still useful sometimes. And obviously, last but not least, we have the engine window itself. So having said all about that, the next block is going to touch upon C# incremental compilation, something I think differentiates Stubble quite a bit from many demo tools, and so I wanted to elaborate a little bit on that. So the motivation for C# scripting comes from a time when we found that adding more and more Lua scripts worked until a certain point, but from that point onwards, performance would degrade and it was no longer possible to do what we really wanted to do. And so we researched whether we could increase the performance for our Lua VM, but we were already pretty much as fast as we ever would be able to get. And so basically we had two options from there. One would be to extract as much logic as possible from our Lua scripts and pull it all into the player and re-implement it as C#, or introduce another scripting language that was just faster. The first option would mean that we would again have problems with backwards compatibility, and we also would reintroduce problems with turnaround times, because the more logic we had in the player, the more we would be forced to go back into Visual Studio when something would be changed. So the first option was really out of the question. We had to implement C# scripting. And C# scripting itself, apart from being faster, also has another advantage, which is that we now could reference external assemblies where the source code was not available directly, which sometimes can be quite helpful. As an example, it's now possible to just reference an assembly that adds gamepad support, and we can then use the gamepad support to do stuff within the demo tool without statically adding gamepad support as a base service to the tool source code. So one problem with C# scripting, of course, is that the more C# scripts were part of the project, the larger the memory footprint of a full compilation would become. And so we wanted to find some kind of a balance, basically because there are two ways to implement C# scripting. The first way would be to unload the old C# source code and then reload the new version. However, in .NET, this is only possible when the app domain that holds the assembly that shall be unloaded will be unloaded. Furthermore, since app domains are isolated in a way comparable to processes, communication between different app domains also would require us to serialize all communication between the tool and the script app domain. Finally, since resources can be defined in script in our system, unloading its app domain would also unload resources, which would lead to unacceptably long update times. And so the trade-off I came up with is something I'm calling incremental compilation. And it basically means that changed scripts should reference as much code as possible that's already loaded anyhow, while only compiling as little new code as needed. And I'll go into more detail how this is done in the next few slides. Okay, so when we compile C# code within Bart, we are using the Microsoft Roslyn compiler. That's the same compiler that's also used by Visual Studio itself, and so we get pretty nice results out of the box. The motivation for incremental compilation is that instead of recompiling everything and having the memory usage of an entirely new assembly, we try to only compile what code really has changed, and obviously also all the types that depend on the changed code. And so that means that we have a little bit more of complexity, because now we have to do type tracking and we have to do dependency analysis, but in the end it's a payoff for memory usage. And before I'm going to describe how incremental compilation is done within our system, let me just quickly describe some terms I'm going to use later on. I have three terms I'd like to discuss real quick. The first one would be the build context, which includes all the data we are handing over to the C# compiler. This includes the C# files themselves and all assembly references, then the optimization level and whether we actually want to serialize the assembly to disk or load the assembly, and various other flags comparable to this. The next term would be the build result, which basically encapsulates the binary executable data the compiler created for us if compilation was successful. This may also hold an optional assembly based on the flags we chose for the build context. And finally, we have the compilation snapshot, which may either be a full snapshot that references all C# files in the demo project, or a snapshot for incremental compilation that references some C# files and some previous snapshots. For each file path in a snapshot, we also have a list of types that are described by the file contents, and we also hold a list of types each of those types references. And we find the types that are contained within a C# file by implementing a Roslin syntax walker and basically just collecting all the types using that. Finally, each snapshot also holds the build result that's associated with the snapshot. Having said that, I will now talk a little bit about the services that are used within Bart to realize incremental compilation, and these are going to reference the terms I just described. So in this illustration here we can see that C# compilation actually depends on the interplay of 3 different services. Right on the right we have the C# service, and the C# service only receives some kind of build context and generates the assembly and the compilation diagnostics, and also gives us information about the types it created. So the question is, which kind of build context should we feed to the C# service? And this is the job of the build context retrieval service. The build context retrieval service itself, however, does not know which C# files are part of our project, because it's entirely independent from the demo system itself. So there is a third service, which is called C# context service, which basically is implemented by the demo system to give us information about which C# files are actually available, where the emission file path should be, whether there is some kind of default assembly references, and so on. Having that kind of information, the build context retrieval service then has to decide whether it should do a full or an incremental compilation, and afterwards generate snapshots from that information the C# service returns, and handle everything so that incremental compilation just works. How this is done in detail is then part of the next slide. Okay, so for incremental compilation, the question basically is, what's the minimal amount of files we have to recompile, and which already compiled assemblies can we reuse in order to get our new compilation state? And for this to work, there are also 2 other things of note. The first thing is that it's not a compilation error to compile a file that generates a type that's also included once by an assembly reference. The compiled type will then take precedence over the reference type, and we will just ignore this specific warning that's emitted by the compiler for us. However, it's not easily possible to reference multiple assemblies that share types with the same full name. At this point, there will be a collision which will lead to a compilation error. Having said that, my approach to finding a sensible combination of previous assemblies and new code is to use good old brute force, which goes pretty much like this. First, we loop through all the file paths, all C# file paths, and for each C# file, we collect the newest snapshot that directly contains the file. And we always guaranteed to find a snapshot, because the tool will always generate a full snapshot when the demo project is initially loaded. Then we look at whether the file has changed by comparing its last write date field with the information that's stored for the file in the snapshot. And if the file has changed, we not only collect the file itself, but we also collect all transitively dependent files. Transitively dependent files are all files that contain types that are dependent on the types from the original file, and also all files that are dependent on those files until we have the transitive hull. Next, in step 2, we look at all possible non-colliding K combinations of all snapshots. So basically, we start with each snapshot in isolation, and then add more and more other snapshots where distinct sets can be formed. And for each of these snapshot combinations, we can find out which types we are still missing and which files we have to add for this reason. So we're actually ending up with all tight definitions of the project. And having done that, in step 3, we can then order those combinations and choose the variant where the number of files we have to compile is minimal. And finally, in step 4, there might be snapshots that have not been used for the collection part in step 1, and so we're just throwing them away, which keeps the number of combinations of snapshots limited, which is quite important because obviously when calculating the binomial coefficient for each k between 1 and the number of snapshots, this would quickly explode otherwise. And having done that, that's how I do incremental compilation selection. Now, in the next slide, the last thing I'd like to talk about concerning C# compilation is external assembly references. So this is just a quick extension to our C# compilation system I added recently when I found that Roslyn has built-in support for something called response files. You may have seen response files before. Unity, as an example, has direct support for response files. There's this cs.rsp file you can add, where you can add additional assembly references and stuff like that. Stuff you can tell, you can give to the compiler to modify the compilation process. And I thought it might be sensible to have something in our tool too. And the cool thing about that is that now we can reference additional assemblies where we don't have the source code, and we can also say parts of our script code might only be made for running inside the demo tool and might be excluded when exporting. Later on, I extended that idea a little bit, and now it's possible to say we want to have a player that is exported either with external assembly references merged into the player assembly or by default left out entirely. And you can see a screenshot here how this is looking. Basically, it's just a text file where we indicate the additional assembly files we want to include, and where we also can indicate any preprocessor symbol definitions. And why am I showing you this? Well, I recently had some time during my vacation where I thought I might just as well use this to do something fun. And so the next slide will be about a little motion capture node I threw together, which is based on working with the gamepad, where you can use the gamepad to record live data and animate various properties inside the system with the gamepad. So on this slide I prepared a video that shows the motion capture node I described before in action. And let me just, before clicking play, elaborate a little bit on what's going to happen. The idea is that when a graph is prepared in a certain way, users could drag in a motion capture node, and the motion capture node would do some kind of reflection on the graph level and find all the nodes and all the associated input pins and provide the user with the user interface when pressing the start button on the gamepad. By the way, based on the brilliant DIM-GUI system. And this user interface would allow the user to calibrate gamepad axis and map the axis to a certain value range that's then used to override the input pin that's selected. And having done that, the user can then go into a record mode and record the data and do some kind of motion capturing. And after the motion capturing is done, the job of the motion capture node is to serialize this data and ensure that the demo system has access to the data as a resource. And this makes everything that's recorded permanent. So let me click play. that the recording is done, there's only a last step here that shows that we actually recorded something and also that we can scrub through our audio in both ways. Okay, so concluding my talk, I think what I learned when building Bart is that the flexibility that's brought by creating an architecture with many extension points might be daunting at first, but can really work out in the long term. The development of the Stubble package alone took over a year before we could even think about using the system for making demos. But now, however, after a lot of work, all the foundations are pretty stable, and so we can invest time in fun stuff such as the motion capturing thing I showed you, and investing in an actual modern renderer. And in that regard, I think that maybe all the best stuff is still to come. Thanks to PS for giving me the opportunity to speak about our demo tool. I hope you found some parts of my talk interesting. Thanks for watching.
Okay, let's try to get Parallax on the call. If Discord allows. Waiting. Okay, I'm gonna do another thing then. I'm gonna give you a link for a website page where you can go. And it's client-based, so you don't need to be on the client. Okay, let's see if this works then. Sorry everyone, we should have planned this a bit better. Like Mike test this thing for the Q&A.
Hello?
Hello, I can hear you. Can you hear me? Hello?
Hello?
Yeah? Can you hear me?
Yes.
Okay, good. And I can hear you. So that means that you can also probably hear yourself echoing on the stream.
Yes.
Okay.
Warte mal.
Do you have a video cam or shall we do this audio only? We can do it audio only if you want.
It says camera unavailable. Okay. Learning for next time. We should have tested that.
Yeah. Also, you should mute the stream. So you don't hear it double. Okay, you're ready? You're ready for the hard questions?
Yeah, definitely.
Okay, they took a while to answer, so I don't think you're that ready, but I'm gonna assume that that's an okay. So first of all, thank you very much for the seminar. That was very insightful. And a lot of people don't really realize how much engineering goes behind a demo tool when you do everything yourself. So that's quite interesting to hear and see all the architecture decisions and all that kind of stuff. So why did you guys decide to, do your own tool instead of just using Unity or Workzeug or whatever?
Well, for me, making demo tools was always the part that interested me most. So I guess the only sensible thing to participate in the demo scene was to just do that and not base my work on Unity or any other tool. And I enjoy learning new stuff and finding new ways to make sure that a community of people can collaborate in a sensible way. And so I've did different demo systems before, and this is just the latest iteration. With latest also meaning that it's already 11 years old, but
a lot of people
it's for the long haul.
Some demo sceners feel like they rather do the tools instead of doing like the creative work. So you're one of the persons who feels more at home doing like the engine and then getting some creative person to do stuff with your engine.
Yeah, definitely. Me personally, I wasn't even that much involved in rendering, and so I guess that's also why the SpacePix demos, at least most of the SpacePix demos, have are not based on rendering itself, but are much more, I guess, successful in the way they try to bring some kind of narrative onto the big screen.
How much do you participate on the demo making of a new SpacePix production? Is it mostly JCO, or do you actually have like input on what he's doing and
well,
that kind of stuff?
So mostly when a new SpacePix demo is about to happen, JCO just takes 1 week off or 10 days off or something, and he locks himself into a room with a lot of beer and a lot of computers and synthesizers and whiteboards and whatever. And then he goes crazy, and afterwards he comes out and the demo is finished. And obviously there is some kind of discussion which direction we want to go or which assets are needed and so on. For me, mostly it's about fixing bugs that came up while JCO tried to use the demo, because that's mostly when stress testing is happening.
You talked about exporting some stuff from Cinema 4D. Do you export from other tools, or is Cinema 4D your main like a way to create models and animations and that kind of stuff?
Yeah, so in earlier years we used a lot 3D Studio Max, and we had a dedicated exporter, but that was with an older demo system. For Bart, basically it came down to just the situation that JCO was most at home with Cinema 4D, and he wrote the first exporter plugin himself in like a wild craze, and then we just extended the exporter plugin, and then we thought, well, we have to do it quicker. We have to build in some functionality so everything just works in one click. And so we introduced the named pipe handlers and stuff like that in order to animate it even more. And now we are currently just using Cinema 4D, but we're also thinking about extending this idea to Unity. And we also thought about giving Houdini a look, but that's plans for the future.
How much stuff do you actually export from Cinema 4D? Is just models, or?
Well, the first iteration was mostly exporting the simple materials we had and exporting the models themselves just as object files, which then we had a file format that basically was binary object files, but very basic stuff. And the idea was that the exporter would generate the node source code in Lua or in C# later on. So you could access any of the components of the scene using that. And that's also how we are able to access all different components inside the scene and basically modify anything, because we have access to any and all of the components. Just using source code, we can change on the fly.
Okay, fair enough. Other notes that I have here, you mentioned you use WPF for things in your demo tool. I heard some bad stories that WPF is a bit hard to work with, mostly from the guys from Still. That tool, their demo tool became like obsolete because no one wanted to work with UI WPF stuff. That they rather do a new tool from scratch than work with that. So why WPF? Do you have any struggles with it? What are the benefits, the downsides?
Well, I would confirm some of it. I guess WPF is just made for making business UIs, and it can be quite successful in that area. I think when you just want to whip some new UI together, then Windows Forms might be faster. It's also not so much new concepts to learn. With WPF, basically, they are reinventing pretty much everything, and you have to invest into learning all those concepts. On the other side, I think concepts like model view, view model, in order to separate the logic and the presentation and the content and glue everything together using data binding is a powerful concept. And in a way, after I understood how it's meant to be used, I enjoyed it quite a lot. Also, at that time, I was working on Hitman for IO Interactive. And their tool is also based on WPF, and I had to do some WPF user interface, some smaller stuff anyhow. So I thought, well, I might as well just go all in and use the demo tool just as my playground. Because mostly I try to combine stuff I'm learning with stuff that's later on useful for me. And I think it worked out quite well for Stubble.
Yeah, I mean, if you're already looking into it, you might as well try to apply it or find like a use for it that forces you to get to know it a bit better. That makes sense.
On the other side, I have to say the pattern editor actually was rewritten 2 times. Because my first naive idea was just to have a pattern editor where each cell would be data bound to the value.
You talked a little bit about using GNU Rocket, but that didn't seem like GNU Rocket. So,
and basically naively thought that's still a good idea, but in reality, data binding to so many cells at one time just kills you entirely. And so after JCO was complaining a lot, which was totally fair enough, because the performance for what he wanted to do was just not there. I rewrote the pattern editor, just trying to find some quick control on GitHub that would be okay, and pulling that in, which was still not enough. And so I ended up rewriting everything a 3rd time, which is just a year ago. And now I think we're quite happy with the performance. But I guess it shows that it can easily go wrong if you are not thinking about subtle stuff like performance.
One question that people were asking on the chat before was, is this tool being used just by Space Pigs, or is it like other groups also using it?
Yeah, so as it is right now, Space Pigs is the one group that actually uses the demo tool, which mostly is about just the people behind it. JCO was, and I see JCO and Moonmaker also here, so hello to them, and also hello to Blockbuster. Okay. Anyhow,
You're in another window.
I'm on Discord and not on Twitch, and I'm out of it. So anyhow, JCO was basically the first user of the system, and so how he used it drove very much where we went with our tool. And since he's not a member of Spectrum, and since what we would do with Spectrum would probably be different from what we did in Space Pigs. It just went that way currently, but we're never saying no, and it might be that.
Have you made any Spectrum demo ever since you started working on this tool? Were they like coded from scratch, or?
I'm sorry, I didn't get that.
Did you make any Spectrum demos instead of Space Pigs demos since you started working on Bart? If you did, were they like coded from scratch, so you didn't use the tool, or what was up with that?
Well, I guess in the end, it just, our last demo with Spectrum was in 2009. And back then, there was also a different group of people. Some of those people are no longer in the demo scene. And so, at this time, a lot changed. And there are still some people, notably Mumek and Blockbuster of Spectrum, who will be happy to do a new demo, but I guess the problem right now is that the focus of tooling has changed a little bit. With Hennecke, it was much more accessible because you could basically just use a library of already existing nodes and use those nodes to just whip up a new demo. With Bart, the focus is much more on coding. And so people like Blockbuster, who is a brilliant graphician, but has not so much experience in coding, is a little bit at a disadvantage right now. And so what we really would have to do is invest more into making nodes that can be reused, because most of our nodes are custom built or copied from an earlier project, and it's much more code driven, as you could see.
Talking about nodes, and I know you watched the talk from Cables GL, so how much of those kind of logics do you have? Do you do like very specific nodes for very specific things, or do you try to make something that is like reusable in the long run?
Well, we have some nodes that are just sensible to have, like creating a viewport, rendering, splitting something into the back buffer, basic stuff, render to texture, certain effects that you use for post-processing. But there could be much more. Mostly, at least with the demos that were made by Space Pigs, much of the logic and much of the work that goes on is done in one node that's basically based on the export from Cinema 4D. And then JCO would take that node and add pins to that node, expose certain properties out of the scene, and then use the pattern editor to animate everything. And I guess it really depends on what demo you are making. If we made demos that were much more effect-centric, then of course it would also make sense to invest more into nodes that you saw in the Cables talk. But many of those we just don't have because we never really did this kind of demo.
Okay. Fair enough. Okay, a couple last questions before I let you go. You have any advice for a new programmer who's just starting to make demos? Should they embark on this journey to make a demo tool that lasts for like 11 years? Or should they just be using Unity and getting stuff done? Can you give some insight and some personal advice on that?
I think when starting out coding, the most important thing is to do quick iterations because it's just not realistic. And I think I also went into exactly this trap. The trap would be trying to do this one really cool thing and investing everything. But because there is so little experience in certain domains, it's really easy to get caught up in some stuff. And I guess it makes much more sense to try to keep your scope rather limited and try to do more stuff over the years and just iterate and try to learn from the errors, because there will be failures, and each failure is also a new starting point, and should be welcomed. And only by acknowledging that process, I think one can get better. And after a while, I think it will just click, and everybody will know by themselves or by himself when he or she is ready to do something that's a little bit more involved and might take 10 years to develop.
All right, fair enough. Good answer. One silly question: why is all demos from Space Pig starting with an SP04 on the beginning? Like, what's the joke?
I think the joke is just to be silly and trigger some people who might compare this to Farbausch. There's mostly nothing serious about anything of Space Pigs. I mean, just look at their info files, look at their demos, and also observe that none of the members of Space Pigs actually are real people. It's just in
Personas?
a way. Well, in the way that the members of Space Pigs call themselves Weichkäse, Camembert, and there are some other names I forgot right now. And there is no
Cheese?
Cena who really is called like that. It's just fake names by a fake group that does stuff that's a little bit different. And I think it should be regarded just as that.
Okay, weird shit to not conform to the demoscene norm.
Yeah.
You guys already, as Spectrum, you already did some weird demos. I mean, there were a lot of weird concepts on your stuff already.
I think so, yeah.
Yeah, so it's nothing new for you. Anyways, the last question I have for you was open source. Are you ever planning to open source Bart, or is it like just a tool for your own use or for JCO's use, apparently?
Well, open sourcing would also mean that I thought that giving the tool out as it was would benefit some people in a serious way. And I think the problem is that if I gave the tool out, then I would have to go over the entire source code, and I would also have to prepare something that's comparable to the tutorials in Tool.io or in Cables, and so on. And as said, we are not even having base nodes to just, draw a triangle on the screen, which is also the reason why this talk was mostly about the architecture of Bart and not about anybody playing around with Bart. Because even though it's a rapid prototyping environment, it's not that easy to just start up the tool and start doing stuff that's immediately visible. It's mostly tied up to us knowing exactly what we need to do and us having a certain workflow. And for all those reasons, we never opened that up to anybody.
So it has like a very unique learning curve that you need to know your own tool very well.
Yeah, a little bit like WPF, but there's no documentation.
That's a parallel debate which could be interesting, like if things should be open source regardless of their being properly documented or not. Of course, everything properly documented is better, but you can still learn a lot from a project even though it's not documented at all. So I don't know if you convinced me completely that that's a good reason, but I respect that your decision regardless. I mean, at the end of the day, it's your decision to make if you want to make it open or closed, so I can understand that.
Yeah, well, say never, never. We will see.
Okay, fair enough. Anyways, thank you so much for your seminar. This was a great session. I learned quite a few things. To start, that Bart means beard. I had no clue about that, which made complete sense because Spectrum was known for the Foliba thing. So from Foliba, you went to beard. That that makes total sense.
Yeah, I actually have no idea whether this idea with our hairdresser game came from anything that was related to Volibear, but in some way we are still sticking with hairs.
Okay, very. That makes complete sense. Anyways, thank you so much for your time. Very interesting seminar. It will be up on YouTube for those who didn't catch the live stream. They can still catch you there. So thank you so much. See you again at the next demo party that we attend. Hopefully, in 2021, things will start to look more possible to do some physical demo parties again. Maybe a revision 2021. We will see.
Yeah, I would hope. I would hope so. It's been too long. My last demo parties, I can't even remember when I was at the demo party.
Yeah.
But it was probably
news,
revision.
Well, not this revision, so previous one, I guess.
Yes, exactly. No, it was the under construction party. That
Yeah,
was
I was going to say there was also the under construction and deadline after revision, so probably had a couple more chances before the pandemic caught on. A couple more news about Inertia before we shut off the stream. The submission system is now open, so grab your vote key by sending us an email or pinging us on Discord, either me or Alien01. And we have another seminar lined up for tomorrow, which will be Ray Marching in Material Maker with Paulo Falcão. I have to talk with him to confirm everything. I haven't talked with him in quite a few days, but it should be ready to go. And the first thing is also that we are starting to open and look for people who want to participate on the official Shader Royale. So if you know anyone who likes to do live shader coding, please encourage them heavily to participate on the Shader Royale. We want to have like massive number of people, not just the number of people that you usually have on the Shader Showdown, but have like a heavy number. I would be happy if we could reach like 20. I think we will probably get like 10 at most, but it would be cool if we got like a massive number of people. That would be a really epic event. So yeah, if you know anyone who loves shader coding, please let them know to ping me on Discord. So I can, inform them of how the format works and all that jazz and invite them to the proper channels. Anyways, that's it for today's stream. We're going to try to find someone to raid. I think Evil was still coding some stuff. So let's raid him and say hello. Let's see if I can figure out how to do the raid. I think it's like this. 1_. Okay, we're about to raid Evil. So bye-bye, everyone. Enjoy your raid of Evil and see you tomorrow.